Yesterday we talked about limits by table and by picture, and today we're going to use algebra and limit laws to solve for limits. Yesterday we had this example, and we had this chart of values to get us our limit. And if you remember, we had some values, and we went and we approached from the left and from the right. We went to our value of 2, and it looked like we were getting closer and closer to our limit value of 1. But remember, here we had an error. And I said, okay, we can say our limit equals 1. Let me show you guys, and some of you may remember this from pre-calculus last year, we can actually factor. Cancel, and then find the limit as x goes to 2 of x minus 1 is equal to, when I plug in 2, we get 1. Okay, limit laws. Please make sure you write these down. I'm going to be looking for these in your notes. Basically, if you're adding or subtracting, you can distribute the limit through. We can pull a constant out in front. You can distribute the limit across multiplication, across division, as long as our denominator doesn't equal 0. If you have a power or a root, you can take the limit first and then put that power in that root out, and then find the limit first and then take it to the power of the root. And then these are the key properties I want to make sure that you guys know. Okay, using limit laws. You have to appreciate the limit laws before I can show you guys some tricks. Okay, so limit as x goes to 3, I could pull the 4 out in front, and I could say that this is x squared minus, I could pull the 8 out in front, of x plus the limit as x goes to 3 of 9. Now, remember, limit as x goes to 3 of x, so limit as x goes to a of x, that's just going to be 3. And then we have 8. I'm sorry, we want to put in here limit as x goes to 3 of x is just that a value 3 plus the limit as x goes to 3 of some constant is whatever that constant is. So really what I did is I just plugged in 3 wherever we saw an x, and when I simplify that, I get 21. So limit of polynomials and rational functions. You don't have to worry about writing this down, but you have to understand the concept that if you have a polynomial, you can just find f of c, f of whatever the limit is. If you have a limit and a polynomial, you can plug in that c value as long as g of c doesn't equal 0. And a lot of times you're going to have to factor and cancel out factors in that case. So going back to this problem, really all I have to do, since it's a polynomial, is plug in the 3, and I want you guys to show me plugging it in, and we simplify to also get 21. Now again, this is only if it's a polynomial. If we have a rational function, let's look at if I plug in 4 into the denominator. We get 16 minus 8 minus 8. That equals 0. So I have to manipulate this in some way. So writing out that limit, and I want that limit written out each time until you actually go through and plug in. Factor the top. Factor the bottom. cancel out that factor. A lot of times that factor is going to be what made the bottom 0. So now still writing out that limit until I plug in. Now we go through and we plug in and we get 1/2. Now finding this limit. Again, when you plug in 4, you get 0 in the denominator, and you also get 0 in the numerator. So a lot of times if you get 0 over 0, you can manipulate in some way. In this case, a lot of times when you have a square root function, you multiply by the conjugate of that square root. So leaving the square root piece the same, but plus 3. Because really I've just multiplied by 1. Again, writing out that limit until I plug in. Multiplying out the top. That turns into a difference of 2 squares. So it's x plus 5 minus 9. Don't multiply at the bottom. A lot of you guys are going to try out to multiply in the bottom, and I don't want you to do that. If you don't multiply at the bottom, you're going to see the trick that is supposed to happen. So now when I simplify the numerator, I get x minus 4. Notice how that's a factor in the denominator, the factor that made the denominator 0. That's going to cross off. So now I can find this limit. So then when I plug in 4, I get square root of 9, which is 3, plus 3, which is 1/6. Okay, trig limits. You need to know these limits, so please have these limits written down in your notes. And we can justify these limits by using tables to actually find those values of those limits. Now use trig limits and limit laws to find each one of the following. So you want to break it up into those trig limits that I just showed you guys. You want to break this up. So what you can do is I have the limit as, I know I had a sine of x over an x. So that's this and one of my x's. Limit as x goes to 0 of 1 minus cosine x on the numerator over another one of those x's, because that's another one of the values I knew. And then what do I have left over? I have this 2 left over. So the limit as x goes to 0 of 1 over 2. So breaking that up. Remember, this limit equaled 1. This limit equaled 0. And that limit is 1/2, simplifying to get 0. Okay, finding the limit. Justify your answer. So with a piecewise function, we have to check and see if the limit at the breaking point at -1 from numbers a little bit less. So I use this top function since that was the function for numbers a little bit less. What that equals. Since this is a polynomial, I can just plug in. So 2 minus 3 times by -1, and that is equal to 5, equals the limit as x goes to -1 from numbers a little bit more. We use the bottom function, since that's for numbers a little bit more. Again, a polynomial, so I can just plug in. That also works out to be 5. Since the limit from the left equals the limit from the right, our limit is equal to 5, even though our function value is something different. Okay, why do we learn limits? Average speed versus instantaneous speed. So the average speed over the first 2 seconds. So basically what this means is from 0 to 2. What you're doing is you're finding the slope of a secant line, or the slope of a line that goes through these 2 points, where these 2 points are on this curve. So I find f of 2 minus f of 0 over 2 minus 0. F of 2 ends up being 64, 2, and I get 32 feet per second. Now the instantaneous is at 2. So basically what you do here is you have the limit as x goes to 2 of f of x minus that f of 2 all over x minus 2. So the limit as you're going to that point of the slope of the line through any point on my curve going to 2. So what that simplifies to be. Actually, this should be a t here because our variable is t. Simplifying that, I'm going to factor out a 16. Ooh, I wanted to carry that up over here. Notice how I'm carrying that limit as x goes to 2 with me. Those cancel, and I get 16 times t plus 2. And then I plug in 2, so I have 16 times 2 plus 2, which is 4, and I simplify to 64 feet per second. Please make sure you fill in that Google form that is underneath this video.